Welcome to RC3's first RC3 alumni webinar presentation. We have Z here from Box. He's going to be talking about Yara and its application in security and threat intelligence and response. So take it away, Z.
Thanks, Ben. Hey, everybody. Good afternoon, good evening. My name is Z, security researcher. Today we'll be talking about Yara and its applications in security intelligence and response.
We have Z here from Box.
So who am I? I'm Zohdi, RIT InfoSec grad from 2014. In the past, I was RC3's president and CTFer in the form of Cyber Wars, NCCDC, etc. My past includes networking, security systems engineering, system administration. Currently, I'm an incident responder, researcher, threat analyst based out of the San Francisco Bay Area. A couple of hobbies of mine: security, racing, and film. So what is Yara? Yara actually stands for yet another ridiculous acronym, convenient. It is a pattern matching Swiss Army knife, typically used by malware researchers, threat analysts, and responders. It's used to help detect, identify, and classify malware samples and their families. Yara allows you to create descriptions of malware families based off of their binary patterns. And the TLDR for what a Yara rule is essentially a set of strings and or hex values plus Boolean expressions for their conditions. Yara was developed by Victor Manuel Alvarez, a software engineer at VirusTotal. Luckily, it's cross-platform. It works on Windows, Linux, and OS X. For the sake of this presentation, we'll be primarily operating out of Linux. That being said, it's really easy to install it in OS X in the form of Homebrew. In Linux, you can use apt-get in Kali or Yum in other platforms. And then in Windows, you can just download the installers and packages directly from VirusTotal's GitHub page. Yara is primarily operated out of a command line interface. That being said, it's not restricted to the command line. You can execute Yara via Python scripts using the Yara Python extension. So let's talk a little bit about who's using Yara. CrowdStrike, Symantec, FireEye, and VirusTotal are all using Yara, whether it be in their professional services or their products. That being said, Yara is definitely not limited to security companies. There are organizations across multiple industries and verticals who use Yara every single day, whether it be in finance, healthcare, and so forth. It's extremely applicable to security operations and organizations globally. So a little bit about common detection methods in security. Many of you are familiar with these two: file signature-based detection and heuristic-based detection. When it comes to file-based detection, you can think of your standard antivirus detecting a malware sample based off of its hash or signing certificate. Signing certificate example being, let's say a file is signed by an adware company, you can detect that. Let's say it's signed by a valid company like Microsoft or Google, etc. You can do heuristic-based detection off a file as well. When a file is detonated, analyzing its execution process and behavior may call out interesting aspects of that binary, such as modifying registry keys, network activity to a C2 domain, adding a new user, and more. So let's talk a little bit about static signature-based detection. So detecting files and such based off of a unique binary string and or hex values is essentially what Yara is doing. If you see in a couple of the screenshots here, we're running the strings command against the binary, and seeing the output, we can see a malicious domain. Now that domain is seen in ASCII format, but it can also be seen and interpreted in the hex value format as well. So a couple of advantages of Yara is that it allows you to detect new strains of malware belonging to a certain family and or class. You can write a rule that encompasses an entire malware family, whether it be pertaining to a certain class of rats or ransomware. Yara is a little bit more resilient toward file tampering. Padding a file to change the hash will not evade Yara. For example, if I have a dark comment rat binary, and I pad the file just to change the hash because the antivirus vendor that I have installed will only alert on that known hash, Yara will still catch it because at the end of the day, despite the file hash being different, the binary contents themselves are still the same. Yara allows you to scan a process's memory as well as memory dumps, and it also allows for the decryption and unarchiving of binaries during analysis. So if you have a decrypted or encrypted binary, you can decrypt it with Yara and analyze against it, or you can unzip it as well. Although it has many advantages, it does have a few limitations, just like everything else. Yara can be evaded via heavy file obfuscation and packers. If a malware author or developer has introduced lots of obfuscation to their file, it'll be difficult for Yara to analyze or interpret that file for anything meaningful. Additionally, Yara lacks output control. And what I mean by this is Yara is a very lightweight and quick engine to run. The output, however, is presented to you in the command line. What you can do with that output, however, is limited immediately with the standard Yara package. However, you can still download Yara modules and Python packages that allow you to do a little bit more with the output of Yara. And you can think of that in terms of trying to orchestrate additional actions against Yara upon output. Let's say you run a Yara rule and it produces a certain output that a file matches a specific given rule. You can then ship off that file sample elsewhere for additional analysis. So let's talk a little bit about the components of a Yara rule. So here we have the rule structure. Every rule, conveniently enough, begins with the phrase rule. After that, you have the rule identifier. Now, the rule identifier can be a couple of things. It can be the exact file name that was seen in that malware sample, or it could be the malware class and or family. After that, you have tags. And tags can provide a little bit more context and information pertaining to that binary. And a couple of sample tags can be ransomware, rat, APT, Russian, etc. Now, once you have that down, you begin the rule with an opening bracket and specifying meta information. Now, the meta information within a Yara rule is not acted upon. It is there for context and information for the analyst and or responder. Samples or ideas of meta values can be the author who created the rule, the hash of the file in which this rule was initially developed for, a description of the rule and what it is trying to accomplish and how it was detected, the date in which the rule was written, as well as the file type, whether or not it's a PDF, an exe, more. Then we have the strings section. Now this is where the meat of a Yara rule is, essentially, along with the condition. You can create variables and specify a specific string and or hex value. This can be a string seen within a binary, such as foobar or maliciousc2.com, in ASCII format or the universal character set. Additionally, you can see that same output or string in hex value and create a variable for that as well. Now, the condition statement here essentially says, if the Yara rule detects a given number of the strings described in the rule itself, alert. And the condition we have in this rule is any of them. So basically, if you were to run this rule against a matching file sample, it would match against any one of the variables, 0, A, or B. So possible values within those Yara rule modifiers. For the meta values, it could be a string, a number, or a Boolean expression. For the string values, it can be text in the form of ASCII or UCS2 in terms of the universal character set. It can be hex, and you can also use regular expressions. For the conditions value, it can be operators that you'd be familiar with if you were to use something like Python or Perl. Offsets, sets of strings, as well as other functions. A couple of cool things about Yara is that you can use multiple rules within the same file. You can create one massive rule that contains multiple rules nested within it. And finally, rules can reference other rules to alert on as well. So here's a very simple sample rule. Let's say we're analyzing a piece of malware and we detected within the strings output that the malware author left in a file path belonging to their own system. This is a pretty good identifier for saying this file is belonging to this specific malware developer who's known for developing, let's say, ransomware, for example. Now we can create a rule that assigns a variable of myTextString to that path. And we can alert on every instance of that file path existing in binaries that we scan against that rule. So let's talk a little bit about creating our first Yara rule. In order to start, we're going to need a piece of malware. And so for this example, I found a malware sample. I scanned it against VirusTotal, and VirusTotal has a detection ratio of 56 out of 60, basically flagging that this is pretty nasty. Now, looking at a couple of the signatures and results for the antivirus vendors here, we can see that some of them call this out as CryptoLocker or ransomware. And so with that, everybody, meet ransomware. This is our file sample of choice here today. So let's do a little bit of static analysis on this file. We'll dump this into our malware analysis sandbox or VM, and we'll run the strings output against it. And we'll see a couple of interesting flags here. Now, we'll see a bunch of crypto modules first thing, which is, sometimes common, but at times, given the times now where ransomware is so prevalent, our first red flag. Going further down in the strings output, we will also see a couple of interesting phrases and sentences, such as you have to send specified amount of Bitcoin address to, etc. You've entered the wrong payment information, your personal files are encrypted, etc. Now, digging further into the strings output, we can also see that there is an IP address listed in this binary. Interesting. Now, when we take that IP address and throw it into passive total, we'll see that there are a couple of write-ups and links on that IP address from various antivirus and security vendors. Interesting. Very, very subtle. So I've written up a quick Yara rule for that specific file. Now, I began my rule with rule, and the rule identifier that I have for that is CryptoLocker. I've added a single tag there, calling it ransomware. In the meta field, I have my name, the date in which I've created this rule, the hash for the file in which I've developed this rule off of, as well as the file type. Now, I have 11 strings that I'd like to key off of. Of these variables, I think the interesting ones to call out would be the IP address in itself, considering that this is unique enough to this binary and activity that we'd want to alert on it. Monetary references here to how much money they are to pay. Any references to MoneyPack and or Bitcoin. And the condition in which I'd like to alert on any file is the matching of 8 of these expressions. Now, I can do more than 8 or less than 8 if I'm confident enough in my rules, but based off of some testing, I figured 8 would be good because any number 8 of these rules usually signifies that a file is ransomware or CryptoLocker related. So how do we test our rule? Well, on the command line, you start off with Yara, and then you have a couple of options to work with. After you've specified your options, you specify the rule file that you'd like to use to scan the file. And this rule file can either be an individual unique file pertaining to ransomware or similar malicious files, or a rule file that contains multiple rules within it, regardless of the malware family. And then finally, you specify the file type or file itself or a directory. Now, the -s flag here prints out any matching strings of a file sample given a certain rule. The -g prints out any associated tags, and the -r recursively searches through specified directories. The documentation and man page for Yara is extremely concise and useful, and I highly suggest anybody who's going to try it out to give it a look. So let's test our rule here. Threw it into a VM, ran the Yara rules, specified -s, and then the rule itself against the file. And we see on the first line that CryptoLocker, the rule, keyed off against the file of cryptolocker.exe. So basically stating that it's a match. And then below, we have the matching strings themselves. Despite my rule stating that I would meet any 8 of the conditions, it's flagged off of all 11 of them. Busted. So just like any other security detection mechanism, the signal to noise ratio is going to vary. Now, you can write Yara rules that have great rate of success, but you can also write Yara rules that are going to trigger a bunch of false positives. For example, let's say you want to write a Yara rule for malicious emails. You can write a Yara rule that says if it has an attachment, then alert. Now, chances are there are multiple emails out there that have valid attachments. So what you're going to want to do is basically write a more effective rule that's a little bit more specific. And so how do we do that? How do we write effective Yara rules? Well, the use of specific strings definitely helps. If you know that a string is specific to a certain type of malware family or class, definitely use it as a variable. The use of rare strings as well, something that you know is very, very specific and not going to be seen across a variety of files. When you specify file headers and file type as a variable, as well as the size, specific string locations, and exclusions, you essentially limit the type of files that can be alerted on as well. And this can be used to your advantage. You can create a Yara rule that specifies only portable executable files and will not alert against PDFs and other file formats. Avoiding common strings used in goodware is highly encouraged. Basically, if you were to do analysis on a standard Microsoft binary, you'd see that there are a bunch of strings in there that would also be referenced in malware just out of coincidence or because they are using similar resources. Finally, testing your rules against good files as well as bad files is always important. Every time I write a Yara rule, I test it against a wide rule set or wide set of binaries that are related to the same file class, outside of that file class, some of which aren't malicious at all. This will help me determine whether or not my rule is specific enough to only catch the bad files, or if I've left something in there that's going to call out anything that may be legitimate. So Yara applied. So Yara is extremely useful. Yara is awesome. In the real world, it's used for forensics, analysis, and hunting. When it comes to forensics and analysis, incident responders, security researchers, etc., will use Yara rules to determine what type of malware family a certain sample belongs to. And this really helps you in analysis when it comes down to narrowing the scope of your analysis. So if you scan a certain file against a number of rule sets and most of them that were keyed off were related to rats, then you have a better idea of what you're working with. You can also use Yara for hunting. Now you can use it for hunting either through the internet or throughout your own organization. Now, for example, let's say you write a Yara rule for a very specific piece of malware one of your employees received. Now you can create a rule that keys off of that piece of malware. If you wanted to know whether it was targeted or opportunistic and if anybody else received that in your organization, you can run that rule against your enterprise endpoint fleet. Additionally, if you wanted to know if anybody outside your organization has ever seen something similar, you can take that rule and you can run it in something like VirusTotal's retro hunt feature that will scan their malware repository for any files that match that rule. Just like other security tools and analysis tools, Yara is most effective when it's used in conjunction with other detection and analysis tools. On its own, it is no silver bullet. Yara is used in malware analysis sandboxes. So despite something like Joe Sandbox, for example, detonating a piece of malware and analyzing its heuristic capabilities and output, it's also going to take that binary and scan it against Yara as well, because that additional context is still useful for any security researchers or analysts. Number of network appliances that also use Yara. This is useful in that if a binary is downloaded over the wire, network appliances such as FireEye and Sitefort will be able to key off of that binary and alert against it, giving you additional visibility on the network outside of the signatures that are primarily provided by those vendors. You can create rules for files that your organization sees a lot of and others may not. And finally, Yara is also used for endpoint security, whether it be in the form of antivirus or host intrusion detection systems. If a binary is downloaded and processed on disk, your endpoint security tool may use Yara to immediately do quick static analysis against it to alert you of any suspicious activity. So there are a number of Yara generators out there online which are pretty useful. I'm very fond of these two right here. We'll try to do a quick demo, but you can download them on GitHub. Great tools. Essentially, what these tools do is automatically generate Yara rules for you given a certain file. So let's see if we can do a quick screen share here against a VM. All right. Call a VM. Cool. All right. So quick shout out to the zoo here. You can download 300 megabytes plus of malware. Super useful for anybody who wants to do some Yara rule testing and analysis. And then here is the GitHub page for Yara Generator. Now, the zoo's download file has a number of malware binaries that you can check out, all very useful and relevant, variety of OS X, Linux, and Windows malware. So I have a couple malware samples here that are Yara related as well as Zeus. We're going to go into the Zeus folder, and we're going to open up a terminal, and we're just going to do a very quick string static analysis against this file. That's calling itself invoice something something.pdf.exe. Very, very legit. Cool. So we'll see that this is a file that says it cannot be run in DOS mode, so likely a Windows binary. Lots of obfuscation here. Probably pretty unique. You can see here some interesting components. Yeah. All right. So let's just use the Yara generator tool really quickly to create a rule for this specific file, just so that I can show you guys how easy it is to use this tool. So we're going to go into this. We're going to do Yara generator, and then we're going to specify our options. And the first option that we're going to do is specify the rule identifier. And for this, we're going to do Zeus RC3 demo, just for the rule identifier. We're going to specify a couple of tags. We're going to do Zeus, and then we're going to specify banking. We're going to do a description of this, and then we're going to say Zeus banking malware invoice. We're going to specify the file type itself, the author of this binary, myself. And then finally, we're going to specify the folder in which we want to run this tool against. Now, one quick shout out to Yara Generator here is that you can actually have a number of binaries in a folder. Let's say we have 6 samples of Zeus. And what Yara Generator will do here, it will actually create one rule that captures any one of those 6. Basically, if we have a malware family sample set of Zeus, we can create one rule that will detect any one of the 6. And this may be useful in the future if we wanted to detect any other files that we don't have that match the rule set we've created. All right, so we've created a rule. And here it is right here. And we'll take a quick look at this rule. Now, I don't imagine it, I won't imagine this be too specific, but the objective here was basically just to show how easy it was to run this. We have the rule identifier here, some tags, the meta information here, which includes my name, the date in which this rule was created, the description, the hash, type, and then the tool that was used in order to generate this Yara rule. And then it looks like the Yara generator tool keyed off of 17 strings, path is directory, and then a couple of obfuscated lines that may be specific to this file sample and are not too common. And the condition in which we are alerting on is all 17 of these. Now, this isn't the best rule in terms of being able to capture other Zeus files, but this rule is well enough to capture this specific file. So if the author of this malware were padding the file to change the hash, this Yara rule would still capture that. So let's do this. Let's test out that rule. So we're going to do Yara-S Zeus. Well, actually, I'm going to do something real quick. Call that. Rename this Zeus.yar. Less janky. All right, so we're going to do Yara-S Zeus.yar against the malware sample of invoice. Oh boy, all right. No sacrifice to the demo god, so this isn't going to work out. That's okay, let's do this. There we go. All right, so running that rule, it says the Yara rule of Zeus.yar against that invoice.pdf file has triggered against these 18 strings within the file of invoice. All right. That was a quick sample of what the Yara Generator tool is like. Back to the presentation. All right, so in closing, what have we learned today? We learned a little bit about what Yara is, some common security detection methods and how they work and where you can find them, how Yara's detection method works and how it's applied, some advantages as well as limitations to Yara, the structure of a Yara rule, a couple of sample rules, how to write effective Yara rules, and how Yara is applied in the real world. So I'd highly encourage all of you to get started with Yara. It's really awesome, very useful tool. Head over to VirusTotal's GitHub page in order to read the documentation on Yara and download Yara itself. There's some great blog posts out there on how to write a effective Yara rule. And there are also some pretty cool GitHub repos out there with Yara rules that are already out there ready to be shared with everybody else, as well as tools that will take a file that you upload and scan it against their repository of Yara rules. All right, any questions? I think we have a live stream with commentary capability, so if we don't get any questions, we can wrap this up. All right, I see no comments. So if anybody has questions now or later, feel free to hit me up on BRC3 Slack. Thank you for coming. Appreciate it.
Thank you, Z, and I hope everyone has a good spring break. See you.
Take care, everybody. Bye.